So, hello everyone and welcome. My name is Matt Corcoran. I'm the Additive Application Engineer with CADimensions. Thank you for joining today. Today's webinar is all about tooling and finding opportunities for 3D printing in tooling. If you have questions at any point, there is a chat function on the side, so feel free to throw your questions in there. If you think of a question later, my email is on screen, so don't hesitate to reach out and we can continue the conversation. There will also be a couple handouts I'll be sharing during this webinar, which will pop up on your screen, and I'll let you know when those are available. So today's focus is first to look at the state of 3D printing. There's this one report that I like to read, and there's a few good charts from it to get some talking points from. So we'll start there. And then we'll talk about the additive value and solution, how to get started with 3D printing in tooling specifically, some considerations when you're 3D printing tools, and then some examples. I'll have lots of pictures and lots of use cases to look at. So the state of 3D printing, this is one report where they send out a questionnaire to a number of respondents in various industries. And there's just a few charts from this that I thought were a good place to start. And I'm also going to share that report in case you'd like to read it yourself. And there's that. So what are the goals of your 3D printing activities, right? It's a good question to start off with, because generally the items listed at the bottom there are kind of how we see 3D printing used in research, R&D, aftermarket spare parts, and use functional parts, which we're seeing more of, tooling, which is today's focus, personal interests and hobbies, of course, the hobby printers. I have one right here with me, and use consumer goods, and then just ancillary ones. They also categorize it into all users and then power users. So power users are those who have been working with 3D printing for 3 to 5 years at least, have invested at least $10,000 in 3D printing, use it on a consistent basis. So what's interesting here is, one, we see tooling is a pretty common goal of 3D printing activities, but we also see that there's a number of power users that are using 3D printing for tooling. And I think that's interesting because 3D printing for tooling, I'll get into this later, can be complicated. I mean, tooling is one of it needs to be precise and accurate. It's very important. It's very critical to the production of a part. So 3D printing and tooling can get very technical and not as simple as just a prototype. This next chart, how important are these factors when choosing a 3D printing material? What matters about the 3D printing materials and the technologies? What's most important? Well, clearly first is accuracy. You need your parts to be accurate. If you design something and it's supposed to fit, it needs to fit. Next, you look at technical properties, the second highest one. So of course, if the material is not strong enough, if it can't withstand the heat, if it can't withstand the chemicals, it's not going to work. And then, of course, is cost. So these top three factors, accuracy, technical properties, and cost, are three of the main things I see all the time that come into play, especially with tooling. Is the tool going to work? Is it going to be accurate enough? And how much is it going to cost? And then lastly from this report is what are you achieving with 3D printing? Because you can use 3D printing for a lot of different things, but in the end you want to achieve something. You want it to make a difference. You want to save money, save time, etc. So you can see at this chart there's a lot of different things that the industry is using and achieving with 3D printing, whether that's part optimization, mass customization, inventory management, reducing costs. But the number one thing is to accelerate the product development process. So we all know getting your product to market fast is important. Getting it out there before the competition is important. It's how the business makes more money. It's how the business grows. So accelerating that product development process can have a direct impact on the success of the business. And we'll see here now how 3D printing can really help you accelerate that product development process. A lot of the customers that we work with, a lot of the parts that I print are used to move that project along. We need a tool to inspect this part. We need a holding fixture so we can move this part along the assembly line. And without those tools, you can't get those products out the door, and that product development process slows down. So those are just a few charts, things to think about as far as the state of 3D printing at the end of 2022. Next, we'll talk about the additive value and solution. So before you can have a solution, you need a problem. So we'll talk about a couple of problems that we see in the industry, whether it's the cost of warehousing spare parts, the cost of freight, or lead time and tooling costs. So before you can have a solution, you need a problem. And right now we see projects being delayed. Lead times that were weeks are now years just to get parts in. So the additive industry has really been focusing on trying to attack these pain points and solve these problems. And here's just a nice graphic showing you, with traditional manufacturing, you have your material resource providers, your manufacturing, your assembly, your distribution. With a 3D printer in-house specifically, you can really streamline that process. So it's well positioned to help overcome the challenges of supply chain or long lead times or expensive raw materials. So with 3D printing, you get parts in-house and on demand, assuming you have one in-house. Fast lead times, even for outsourcing, even if it's not a tool you can make in-house and you have to buy it somewhere else. 3D printing, generally speaking, is going to be faster. It's just a faster process, especially for a service bureau with a lot of machines. They can throw your part on next day and have it ready for you. Design freedom. So that's one of the biggest things, especially with tooling and 3D printing, is the manufacturability and then the design freedom. So increasing the complexity of a part with traditional manufacturing would normally increase the cost, but that's just not the case with 3D printing. Whether it's a simple cube or a complex lattice structure, it's going to print the same and it's going to relatively cost the same. So that's one of the big things with tooling, especially the design freedom. You can increase the complexity of your tools. You can make unique parts without really increasing the cost. Along the same lines is part consolidation. So this design freedom allows tools that were previously assembled from multiple components to be consolidated into one piece. So you might have a multi-piece assembly tool that you're using to, say, mount molding on the side of a car, whatever it is. With 3D printing, it's a lot more feasible and easier to print that in one piece. So you get less parts you have to deal with, faster turnaround time, and usually a more optimized process. Production line automation. I've had the opportunity to walk through a few different facilities this past year where I've seen them using 3D printing to automate their production line, to pull parts from robots onto other trays, moving it along. So 3D printing with tooling, especially, the production line automation possibilities are endless. Another good point is supply chain resilience. So you may have this tool that you're ordering, whether it's a mold or a fixture or a jig, whatever it may be, and there might only be one supplier of that can make this, or a couple suppliers of that can make this. Or maybe this one supplier has been making this tool for so long and they do it well, and to try to find somewhere else that can do it is just not feasible. Or maybe you don't have the capabilities to make the tool in-house yourself, so you find someone else that does. Well, the cool thing about 3D printing is, once you have a tool that works for 3D printing and you found that this is a good fit, you can order that 3D printed part from a number of places. Sometimes it matters what printer is used and what material, but if you can dial that in, that only increases your supply network, right? Because there may have been one person you could go to for this tool, whereas there's multiple 3D printers across the world, and a lot of them in Syracuse as well. So it just gives you that more resilience. If you can 3D print your tools, you can buy them from more places. So next, I just wanted to show the three main things of 3D printing that we look at. And today we're obviously focusing on tooling. So the prototyping we see all the time, that is the bread and butter of 3D printing, where the technology and material is important. At the end of the day, you just need a fast part that works. You need it cost effective, and you might only need one. It doesn't need to be repeatable necessarily. And so that's prototyping. With production, it limits you to a certain class of machines that can achieve the throughput you need, or the certifications or the mechanical properties for production. So that conversation tends to streamline itself really quickly. But with tooling, well, at the end of the day, you need the part to work. So whether it doesn't matter what technology, what material, especially if you're ordering the part, You really have everything at your disposal, which is why I find tooling to be very interesting for 3D printing. This past year, I've had a lot of different, printed a lot of different tools. We'll see pictures of some of those. And it's always a challenge when someone comes to us and has a tool, a jig, a fixture, and they're interested in printing it, because I have the full technology and material at my disposal, and there can be very unique requirements that might make one printer fit but not another. So it can be a challenge to identify what printing technology is the right one. But that's what we're going to talk about on the next slide. And that's how to get started with tooling. And there on the right, you can see an automotive flange hemming tool being used. It's a really big part. It's cool. So how do you get started? First, you show up to webinars like this. You educate yourself, you inform yourself, and you learn what's out there. You learn how other industries are using it. What benefits are they seeing? What challenges is it solving? So you can already check that box. And then start small. Always, as I continue going through, I'm hoping to kind of jog your memory and get your brain thinking about the different tools you might use, the different projects you might be working on, and how you might be able to take one piece of that and see if you can print it. Give it a test. Maybe it'll be cheaper. It'll almost certainly be faster, and go from there. And of course, test and report. Try out a tool, test it, keep notes, report, discuss with your team members. Did this help us? Was this faster? Was this cheaper? And keep a catalog, because the more use cases you can build, the more it will make sense to actually bring a printer in-house. Collaborate. So like I said, with choosing the right technology and material for tooling can be very tricky, but that's why there's resources like us available. So I really, anytime you have a question, if you can print something or should you print it, please feel free to reach out to me, because that helps me learn, and I like to take the knowledge that I have and share it with the industry. So collaborate, and that's how you'll continue to learn. Identify weak tooling. So what I mean by weak tooling is sort of everything down here. The tooling that is causing, whether it's delays in production, whether it's supplier issues with the tooling, whether it's they just don't make it anymore. I try to identify which tooling or which projects were affected by the tooling. So analyze the project lag. When was there downtime? Why was there downtime? Was it because of a tool? Was it because you were waiting for a tool? And what does that equate to in loss of revenue? So if you can identify those common failure points, keep a record of those, and again, collaborate with other 3D printing industry experts, you can very quickly identify some areas of opportunities for 3D printing your tooling. It might not always make sense to do it, but you don't know until you give it a shot, honestly. So what are some considerations when you 3D print a tool? There's considerations for prototypes. There's considerations for production. There's a lot of overlap with those, of course, but what do we consider with 3D printing tooling? High precision and accuracy. A lot of times the quality of the end use product that we buy on the shelves is directly associated with the quality of the tooling. So if you can have tooling that's highly precise and highly accurate, it's going to be a good thing for production. So with 3D printing, you need something that's highly accurate and precise. What else? Technical properties. You might need heat resistance, chemical resistance. It might need to be very strong, very durable, non-marring, electrostatic dissipative, isotropic. Maybe you need it to be porous, which we'll see examples of. So there's a lot of different considerations, and generally when I'm working with our customers, we kind of run down a list. What do you need this tool to do? All right, I need it to achieve a temperature of 80 degrees C. I need it to have some elasticity to it. I don't want it to mar up my part, and I need to be electrostatic dissipative. So we run through these considerations and narrow down which material, which technology would actually work. Quantities. Generally, when we're talking about tooling, and from what I've seen, you're looking at quantities of 1 to 100. There might be small assembly brackets that you need 1,000 of, but generally speaking, 1 to 100. We print a lot of one-off tools, a lot of sets of like 5, 12, So those are some of the quantities I've seen with tooling. And of course, 3D printing is great for one-offs, because if you only need one tool and it's a highly precise tool, you need it quick, your production line is down, it's going to cost you a lot in money and time to try to get it traditionally manufactured, just one part. But with 3D printing, it's a lot more feasible. The size of the part. 3D printers are big and they're getting bigger, but if your part is too big, you might not be able to use 3D printing, or you might just have to print it in a few sections and piece it together. On the flip side of that, if your part is very, very small, then maybe you won't be able to use 3D printing. However, with some of the newer printers, the tolerances and accuracy and detail, feature resolution you can get is pretty impressive. Part optimization for printing. Not only can you optimize the tool, but that can help you optimize the finished part. So use injection molding as an example. There's 3D printers that can print injection molds. You can't get as many shots out of them as a steel mold, but what they can do is help you optimize your tool and your part. So you print your tool out the next day, you get 50 shots out of it, you look at your finished part, make adjustments to the tool, make adjustments to the part design, and it accelerates that product development process. Repeatability. Sometimes repeatability is very important with tooling, sometimes not. It might be one quick job or one quick thing you need, but generally speaking, you need these tools to be reliable and repeatable, because if they do break and you need a new one, you don't want to be left not knowing where to get it or when you can get it. So with 3D printing, it's very repeatable. If you find a tool, you print it, you know it works. 6 months from now, it's starting to fail. Well, you can just print another one. I mean, you don't need to set up new tooling to print this tool. I mean, you're not CNCing it, you're not using any lathe operations. So 3D printing, you print the tool. 6 months later, you need another one. You load up that file again, and you're printing. So 3D printing your tooling is very repeatable and reliable. And then lastly, is it faster and cheaper than what you're doing now? That's a lot of times what it comes down to. Is this tool significantly cheaper or significantly faster for me to want to change my process? Go through that uncertainty at first. So that's what we consider a lot. It's like, yes, could you print it? Probably, but is it going to be faster? Is it going to be cheaper? Maybe not. So to continue these considerations, these are just some questions that you should ask yourself, or that I'll ask our customers when we're going through these types of conversations. Is how many tools do you need a year? How many tools do you use a year? How many do you outsource? How many do you make in-house? How much is that costing you in dollars, and how much is that costing you in time? So if you can answer these 5 questions here, that'll paint a pretty good picture of whether or not 3D printing is a good fit for your tooling. If you're only outsourcing a handful of tools a year, then maybe it wouldn't make sense to bring a printer in-house, but it might still make sense to print those tools instead of how you're normally outsourcing them. And if you do have a printer in-house, or if you do have a tool and die shop in-house, I mean to say, and it's always overloaded and it's always running behind schedule, or you always wish you had more machine time, if you can identify a few projects, a few tools that you can print, that'll free up a lot more machine time, which will allow you to accelerate the product development process. And then lastly, these are 2 of my favorite questions I get all the time. First is, can I 3D print this? And then I usually like to ask back is, should you 3D print this? And that's what I spend a lot of my time figuring out, because at this point, the question, can I 3D print this? The answer is probably, or yes. But then should you is the bigger question. So if you're ever wondering, can I 3D print this, or should I, send me an email and I can give you my opinion. So once you have all these considerations, you know what your part needs, what accuracy it needs, what tolerances, what heat resistance, when you need it by, all of that. Once you have all that, you still need to know which technology and which material is going to work for you. So luckily, we do have a guide that we put together. I'm going to share it now. It's a high-level guide about choosing the right technology for tooling. We look at FDM, powder bed fusion, DLP, SLA technology, and talk about some of those other different considerations and which technology might be a good fit. So if you wanted to take a look at that, you can at least apply that to think about some of the parts and tools you work with and see if any of those technologies might be a good fit. The other thing to consider is, well, I have this tool, here's an example. I have this tool and it's starting to fail on me, but it was made 50 years ago and that company's out of business. I don't have a CAD file. Maybe I have a print, but it's not fully dimensioned. What do I do? Right? It's like, I want to print my tooling, but a lot of our tooling was made years ago, or we just don't have CAD files. Well, that's where reverse engineering comes into play. So I've done a lot of reverse engineering over the past couple of years, and it's very tricky, but it's very rewarding. So a lot of the tools, some of the tools that we printed this past year have been customers coming to us with a picture or a physical part, and they say, hey, can we make this? And luckily we have a scanner, we have reverse engineering capabilities, and so we can. So with reverse engineering, it allows you to reclaim that lost tooling. So you may have a part file, you may be able to model it up, but if it's ever a more complex tool that maybe has wear marks or unique geometry that you can't mic out or grab with calipers, then try 3D scanning or reverse engineering, because the savings you can get in time, in headaches, in money for getting that tooling back into the production floor and getting the jobs running again can really make a difference. So don't forget about reverse engineering. You can always remake the tool. So next, I wanted to go through a few examples, some pictures, some use cases that I've seen that are interesting and hopefully will give you a good broad view of how others are using 3D printing for tooling and how you might be able to. So first is this example in the food industry. So they had a machine that wraps the chocolate bars on a conveyor belt, and one of the arms broke, and the existing metal part it was replaced 3 times a month. So they needed a better solution, and they looked towards 3D printing. And with 3D printing, they were able to print this arm in nylon 12CF that you see here. It reduced their machine downtime. It took an hour to print the part. So within an hour, you're back up and running, or if you have a handful of these lying around, you're virtually never down. And so the return on the investment they saw, it returned in 6 months. So I do have a video of this playing here. So pretty cool. There's a lot of applications within industrial equipment and spare parts with machines, different arms, different packaging equipment, just like you see here. So I thought this one was pretty cool. And for this one, they needed a strong, durable part with some give to it, some flexural strength, also some rigidity, and they needed it fast. So FDM, nylon 12 carbon fiber, was a great fit. So just an example of identifying which material and technology is the best fit. Sure, you could have printed that part in a number of different technologies, and it might have worked just fine, but it might have been more expensive or taken more time. So FDM was really the best fit for this. So next, I wanted to look at some examples within the electronics manufacturing industry. I've been doing some digging into this a little bit more, given that in Syracuse we have Micron building a facility soon. So there's a lot of talk around electronics manufacturing, and I figured it'd be cool to see where 3D printing fits into that. So first, we have these surface mounting nozzles to mount components onto a circuit board. So this is showing you the traditional manufacturing time and cost versus the Origin 1, which is a DLP printer from Stratasys. It uses a material called Formula 1, having nothing to do with the sport. So you can see with this SMT nozzle, The normal composite traditional manufacturing take about 3 weeks and $300 each for that small nozzle. With the Origin One in printing, it was 3 hours and $3 in resin. So right away, you can see it's faster and cheaper. So it was a good fit. You also have grippers. Traditional manufacturing would be out of aluminum, take a couple weeks. They'd be $500 a piece. With resin printing, it's an hour and a half and $1.50 each. So much, much cheaper and much, much faster. And then last is these JDeck trays, it's a standard tray form factor used to hold and transport electronic components. So I didn't know what JDeck stood for. It's Joint Electron Device Engineering Council. So you learn something new every day. But this tray in itself, you can see it's a complex part that would probably, you'd be spending tens of thousands of dollars on a tool, on a mold if you were going to injection and mold that. But with 3D printing in 14 hours and $140 in resin, you have your tray. So it just shows within the electronics manufacturing industry, it's a very precise, very technical industry as far as what materials you can use and what parts can actually be printed. But we are seeing some applications within that industry, especially with this electrostatic dissipative resin. So I'll be continuing to watch this one closely. Next are a couple just great reads for whenever you have time. I'm going to share those as well. The first one is talking about production tooling with additive manufacturing. So using tooling that is actually used on the production floor, not just some testing fixture, inspection fixture, but production tooling. So that's a very interesting read. And then from East West Industries is a use case on soft jaws. It's a pretty slam dunk application for 3D printing tooling. So I encourage you to read those because it's important to educate and inform. So lastly, I have a slide with just a bunch of examples of different tooling that you can make. It's hard to think what you could print until you see what has been done before. So these are just some of the different tools that I've had experience printing and working with, whether it's end effectors, drill guides, inspection fixtures, holding tools, mounting tools, welding fixtures, injection molds, CNC fixtures, sacrificial tooling, composite tooling for layups. So you can see pictures here. We have sand casting, Ford mounting fixture. So that's used to actually mount car panels onto a Ford Mustang. I've seen this part in person. They had it on the Stratasys truck show that we did. And it's really impressive to see how it's durable, but it's lightweight because it's not solid material in there. If you were to machine that out of aluminum, it would be 5 times the cost, twice as long and heavy. But with 3D printing, there's an infill in there. It's not 100% dense. So it's really cool to see kind of the benefits you can have from 3D printing a tool like that. Then there's heat insert cradle. So that's a polyjet part. The white color outer surface is rigid, and then the black is sort of a soft touch, non-marring material. Then there's also injection molds. That's a very common application that we see or at least talk about. You can do it with polyjet with digital ABS. What we've also seen is the Origin One coming into play, DLP technology coming into play for injection molds. I've been printing some of those, and our customers have been testing them. Then you also have dip molds. So that's from a company called Echo Footwear. They printed the dip mold on the Origin One and were able to use it in production to make their actual shoes. So that was pretty interesting. So with that, I'm going to say thank you for joining. If you have any questions, please feel free to reach out or throw them in the chat right now. I'll hang around for another minute or so. Hopefully you're able to take something away from this, seeing the different types of tooling that's out there, what things you should be thinking about if you want to get into 3D printing your tooling, and how it's really important and beneficial to reach out to those in the 3D printing industry. Because if I didn't know much about 3D printing, I don't know where I would begin with 3D printing a tool, especially with the how critical and important these tools are to production. So with that, I'm going to take one more look, see if there's any questions, and wish you all a great day. That was my last webinar for 2022. I've done a few of these now, so if you have some time and are interested in different 3D printing topics, feel free to take a look back through the catalog, because there's a lot of different topics that I've talked about. So thank you all, and I hope you enjoy the rest of your day.